we're looking at it with the colors of visible light, red, orange, yellow, green, blue, indigo, and violet. And really hot stars are going to shine a little bit more blue, and really cold stars are going to shine a little bit more red. Medium kind of hot stars, if we're basing it on, like, you know, chicken sauce or buffalo sauce is hot, mild, and medium, whatever. Medium grade stars, like our sun, are going to be yellow. Okay, kind of that mix in there with the yellow color. And if we notice the temperature, we did say last chapter that the sun is 6,000 degrees, the photosphere 6,000 degrees. So stars that are similar to our sun temperature-wise at the surface level are going to be yellow. Okay, our sun is not the hottest star that exists in the universe. It's not the biggest star that exists in the universe. Okay, it only appears as such because we're so close to it. Okay, there are larger stars, there are smaller stars, there are hotter ones, there are brighter ones. So our sun is kind of an average type star when we're looking at all of them. Okay, but temperature, making sure that we understand that temperature, really hot stars are going to be blue, medium are going to be yellow, and really cool stars are going to be red. Okay. I've kind of already mentioned that, where we see differences amongst the stars, just like amongst you guys, all different sizes and shapes of everything. Same thing with our stars, okay? And a lot of it depends upon how close or how far away the star is from us or from Earth, okay? And the farther away it is, the dimmer it's going to appear. The closer it is to us, the brighter it's going to appear. One thing that we also see, since we're talking about things that are outside of our solar system in the vastness of space, we have to come up with another unit of measure to measure distances between these objects. And that's where our light year comes into play, okay? But a lot of times people tend to think that the light year is a time measurement, because we see the word years, but it's a distance measurement, okay? It's the distance that light travels in 1 year. So we need to, again, this is kind of our second main thing to take away, to remember that the light year, it's a distance measurement, okay? It's not a time frame, it's a distance measurement. Just like feet and inches, centimeters, miles, we are measuring a distance when we're using light years, okay? And then kind of the last thing that we see here, looking at the brightness level of stars, also known as magnitude. We have these two different types of magnitude measurements. One is the apparent, how it appears from us here on Earth. So again, the closer it is to us, it's going to appear brighter. The farther away, it's going to appear dimmer. This one takes distance out of the equation. It kind of lines them all up equally and compares their brightness to each other that way. Okay, and that's the absolute magnitude, which is how bright the star actually is when we compare them to all stars. All right, and this again is where our sun kind of falls in the middle. It's not the brightest, it's not the dimmest, it's kind of right there in the middle. Okay. And then lastly, how we compare temperature to brightness using an HR diagram. We will be looking at an HR diagram tomorrow and practicing how to plot some stars and things like that. So it might look a little bit like math class in here tomorrow when we're using our X and Y coordinates to plot things, but it's just looking at stars, temperature on the bottom, and brightness along the Y-axis there. Okay, so that's our kind of our third thing, and we'll talk more about the HR diagram tomorrow. All right. Yes, Tim. Well, we're not calculating slope or anything, but we are using kind of like that first coordinate of an XY plot system, where we've got an X value that we're looking for and a Y value that we're looking for, and then we can match up stars based on temperature and brightness. So, yeah, but we're not going to be like calculating the slope of this line or anything like that. We're just placing stars on it based on those two things. Okay. All right. Any other questions that you guys have from the video or from this? I don't see any other hands. No? Okay. All right. So let me get out of here. And let's go to our agenda. Okay. So now that we've watched the first part, or we're just about done with the first part, the time that you guys have remaining is yours to work on the following things. First, if you did not finish the notes video, maybe you have a minute left, that needs to be finished first. Okay, so the notes video, 25.1, that needs to be finished first. Okay, second, the vocab is due today. So once the notes video is finished, if you didn't finish the vocab, that needs to get done. And then third, if the vocab is finished, you can continue working on your outlines wherever it is that you left off. Okay, but first, the video needs to be finished. Second, the vocab, since that's due today by the end of the day. And then the outline for tomorrow. As I'm looking in Classroom, there are about 20 of you guys that need to finish up the vocab. So make sure that you do use this time that I'm giving you to complete it if you haven't already done so. Okay, so notes video first, vocab second, outline third. All right. Okay, I will be here if you guys have any questions. Please use the chat since your classmates will be watching videos. And for those of you who have not yet started that video notes, you need to get that done by the end of class.